channel. So let's see, according to the syllabus today, oh, we're still looking pretty good. All right. So we're gonna start on the normal distribution. So the key for today is this. Need your pullout. So if you need a minute, find it, because you're not gonna be able to do anything without it today, unless you're using technology, which I will also go through near the end. But if you do not have this and you do not use technology, you are not going to be able to do anything from chapter 6. All right, so you need this today. If you have a TI-83, 84 calculator, I'll tell you how to use that. My Excel users, I'll tell you how to use that. But we're going to kind of go through all of this together. So please find your pullouts, find your calculator if you want to do some calculations. Make sure you have your, and then we can do some Excel as needed, because I know a lot of you are kind of Excel savvy. Some of you missed last week's class, so our optional class. If you did attend, make sure I got your bonus points. I think I got everybody. But I forgot what I was going to say. Yeah, it'll come back to me. So this morning's class went fairly well. It was algebra, so it's a little bit easier to teach via the internet than stats is going to be, but I think we will definitely make it. So I'm about to bring up my whiteboard. So once I do that, I can't see you all any longer. So if you have a question, you need to just unmute yourself and just ask the question. I still don't think you'll see you because my whiteboard is going to be the background anyway. So, but please interrupt if you have questions. If I ask for people to do calculations, it's up to you if you want to share your results or not. Again, you don't have to, but I'll wait a minute to see, and then I will just kind of give the answer. The key to today's lesson, because we are using the table, if you are not getting the values we're getting, I need you to tell me, because if you cannot read this table, you're not going to be able to solve any single problem. Right? So I need to know if you're struggling. Right, and I'll try to end class a little early, so those people that just don't like to ask in front of anyone else can have a few minutes to ask. All right, so any questions on anything so far? All righty, so I am going to share my content, whiteboard. All righty, and if you can't hear me, please, oh, I don't want to do that. I can't see chat no more, so, but definitely unmute your
whiteboard if there's something on it that we need.
Do what?
Do we like take a screenshot of the whiteboard?
I think so. Yes, you can.
Okay, cool.
I don't know. So on mine, I tried to get someone else to do this earlier, but I don't think they were comfortable with technology. So can anyone write on my whiteboard right now? If you have that capabilities or know how to?
I don't think I can.
I have a touch screen and I can't.
Okay. So you don't have any little keys at the bottom then, huh?
No.
Dang. I was hoping you guys would be able to save the, oh, someone just wrote.
Hey.
Who wrote in green?
I did.
I don't know who I did it was, but because all I see is a whiteboard. So where are you down where you see the colors? Is there like 3 little dots to save this whiteboard to photos? Do you see that?
I don't see any colors.
Yeah, it depends on what version I guess you're using. I'm on my iPad. I don't ever use my desktop, but you all should be able to write on this somehow. We'll keep playing around with it. But on mine, down where I have all the cool features of writing and erasing and doing things, it has kind of where the delete used to be, because whoever deleted their green had that option. There is a little place to add more boards, and mine has 3 little dots that says save to photos, but it good because I'm on an iPad. So I don't know if there's a way, if you click on it, to bring up some options. If not, I'm recording this right now, so you will got to go back to the video and watch it, write down whatever you want to write down as well. I could try to email the photos, but I don't think it worked real well. I did it with my person I was just tutoring an hour ago, and it is an option to see. But we'll get started and see how it kind of goes. So chapter 6 is all about the normal distribution. So the normal distribution, like we have learned, looks like a bell curve, right? And it is always centered at the mean. It's also centered at the median, as well as the mode. So it's one of those unique distributions that's centered at all three measures of centered that we learned back in chapter 3. We also need to know our standard deviation. All right. Now, the good news, I have to give you these, right? Because in our class, you actually will not learn how to calculate them. So I will always give you this information, right? So this specific one, if my mean is 0 and my standard deviation is 1, this is called a standard normal, right? Because it is centered at 0 with a deviation of 1. And that's what we're going to kind of play with a little bit today is the standard normal. And then we'll go on to things that are not centered at 0, because very few things in the real world are actually centered at 0. Just an interesting fun fact. If you are paying attention to our lovely coronavirus and the math modeling they're talking about right now, and they keep talking about the leveling out the curve, they are talking about the normal distribution. They are trying to change, based on the math models, the normal distribution and try to get our curve not to be so high peaked. So what you're learning in class right now is exactly what is happening with everyone that's doing the analysis of the coronavirus, trying to figure out how to slow the spread based on what we're learning today. So it's a good example of what we're doing is actually outside the classroom. So here we're centered at 0. Now, let's do a problem. So say I want to know the probability that I am less than 1.24. Right, so what is the probability I'm less than 1.24? So the first thing you should always do with doing the normal probabilities is draw a picture, right? I think it's very useful to draw a picture because it will help us a lot. So if I'm centered at 0, 1.24 we'll say is probably somewhere about right there, right? And then I draw a little line going up, and then with my words less than, I would be coloring to the left, because all of these values go in this direction are less than 1.24. All right. So now that I have my picture drawn, we need to use this formula. Z equals x minus mu all over sigma. Now, if you look at your little pullout under chapter 6, you'll see this formula listed right there. The very first formula is called standard score, right? And one thing that is not on your little pullout, which I like to include, is parentheses, right? You must do the subtraction before you do the division. So if you type all this in your calculator at one point, you need to put the parentheses in. So I like to add those. So now it's just putting numbers where they go. And this is why knowing your symbols has become extremely important. Well, we know where our mean is. It's 0 in this case. We know our standard deviation. It's 1. And our x is our event, and it's what we are looking for, and it is the number in the equation. It is also the number that I added to my graph. So if I take these numbers and I put them into the equation, 1.24 minus 0 all over 1 equals 1.24. No, this only happens for standard normal, right? Because 1.24 minus 0 stays 1.24, and then 1.24 divided by 1 stays itself, so it stays 1.24. Make sure you're paying attention here. You will only get the x value if you are a standard normal. Any other time, you're actually going to get a different number. But I like to start with the easiest problem first. Any questions on how we've calculated this? All right. Now, question? All right. So now, grab your little pullout. And I can switch to my camera if I need to. I'm going to try not to right now, because if I do, it erases my whiteboard. I learned that last class. But if so, I can always recreate it real quick. So, all righty. If you open up your pullout, you see they go to where it says z-scores, hence the formula, the z. We have negative z-scores and we have positive z-scores. Well, in this case, our answer is 1.24, so that answer is positive, so we are on the positive side. Now, if you look at the top, before you even look at any of the numbers, you notice there's a bell curve drawn on both sheets. And if you pay attention, it is colored to the left. To use this table, it is based on everything being colored to the left. That is why it is so important to draw your little picture every problem, because it will tell you how to read this table. All right, so we are colored to the left, just like the thing, so we are good to go. Now, how do you read this table? If you're on the positive side, and you see the big word table alpha 2, right? Right below that, you see this little z. Those are your z values. In the first column, I am in the ones and the tenths place, basically 1 decimal place. In the top row, I am in the hundredths or the 2nd decimal place. Anytime you calculate a z-score, you want 2 decimal places. So, to do this, first I am going to look for 1.2. So I go down the z column and I find 1.2. Then I am going to go across the top until I find 0.04. So I find 0.04 in the very top. I draw my finger down. I draw my 1.2 finger across. And my answer I get is 0.8925. This is extremely important. You need to speak up if you do not see where I got that number. And hopefully everybody's playing along.
I do not know where you got that number.
Yeah, me either.
Perfect. All right. If you want this screen, you need to take a screenshot or something, because as soon as I come off my whiteboard, this is all going to be erased. I'm going to try to save it to my folder.
I don't know how to take a screenshot.
What kind of computer are you on? Windows or Mac?
Chrome.
Usually it's print screen, the print screen button.
Yeah, print screen on Chrome, I think. They might have snipping tool on Chrome.
It's fine. I'll just take it with my phone.
Okay. If you're on a PC, there is a snipping tool. And if you're on a Mac, it's Command-Shift-4. And you can highlight and take a picture of everything.
Or you can do Command-Shift-3 and just take a screenshot of literally everything.
There you go. So that works as well. Right. All right. So I'm shrinking this down now. I saved it so if I have to get back to it. So I wish there's a way I could just shrink. Maybe if I do that. No, that's part of my Zoom. I can't do that. All right. So stop share. And let's see if I can do this. Switch camera view. All right. So here is the positive z-score table.
Okay.
And there is my little z. So I come down the first row until I find 1.2. All right. And then it was 1.24. So I come back up here and you can see 0.04 at the very top, right under the word left. Now put your finger there on the 0.04, the other finger. Hopefully you still have a finger on 1.2, and then move your fingers across and down until they touch each other. And there is the 0.8925.
That's kind of magical, but like, what the heck does 8.925 mean?
That is a percentage. That is, I have an 89.25% chance of getting the number 1.24 or less.
Okay.
So what this table means, and I'll go back to whiteboard here in a minute. Z's are events. Notice it's right there on the line. Any number that is on this line is an event. The mean is in the center. It is an event. The Z is on the line. It is an event. X, as we have already been talking about all semester, is an event. So the numbers on this line are events. The numbers in the shaded region are probabilities. These numbers inside of the chart are probabilities. These are probabilities that correspond to every single one of these Z events. So if I have a positive, I'm on this side. If I'm a negative, I'm on this side. But notice, even on the negative side, I am still colored to the left. I must be colored to the left to use this table. All right, so any questions on the table?
Is there a scenario if it's colored to the right question mark?
We will be doing that one in about 3 minutes.
Okay.
Yes, we're gonna do all kinds of different ones, practicing with this table. The key is if you can color, it will help you solve your problem. It's not required to color, right? I'm not gonna take points off if you don't color, but typically for most of you, you won't get the question right unless you do color. So I highly encourage you to color. All right, so let's go back to our whiteboard. Any other questions before I go back to the whiteboard? No? Okay. So, nope, that's not what I want to do. Share content, whiteboard. So go back to drawing our normal again. Well, center the mean, my standard deviation. That is always the case, right? And then because we're doing standard normal, this is always 0, and this is always 1. I don't know why I wrote equal sign there. So we just did the probability of less than 1.24. Yeah. Less than 1.24. And we got the answer of 0.8925, remember correctly? Yes, 0.8925. So let's do another one. What is the probability of less than negative 0.36? All right, I'm gonna give you a second. See if you can find the number in the table. And then I will continue working. Again, if you want to answer, you can. I'm not saying you can't.
Is that negative?
Yes, that's negative. Thank you.
Is there a way to make the little camera doodad picture thingies that like are in the corner over here go away?
Yeah, if you click on the
But
minus, I think it is, because mine's gone. Yeah, if I click on the little minus, it shrinks it.
thank you. That's helpful.
Yep. All right, anyone daring enough to share their number? Or are you still working? I think we're still
I
working.
got point .3594.
Indeed.
3594 is an answer I heard. All right,
Indeed.
let's draw a picture, and I heard someone agrees with you. So, set it at 0, standard deviation of 1. So negative 0.036 is right here. Bring up my color scheme here. I want less than, so I'm coloring to the left. I am going to use my Z formula, even though I don't need to, just to get practice at it, because we will have to use it in a minute. Of negative 0.36 minus 0 all over 1. So this
Bless
equals,
you.
thank you. Negative 0.36, just because of 0 and 1s, it will not always equal that. Make sure you remember that. So now I go to my table, negative 0.36, 3594. Everybody look at that for a minute. If you did not get it or have questions, please ask, because the questions are just going to keep building off this. So these are the easiest to do. So I want to make sure we have this down, and then we can move on. All right. No one seems to have questions, so we'll move on. And we'll create a new page. I can come back to this if we need to. I'm not deleting it right now. I just created a new one. So what is the probability that I am more than 1.72?
The ending results have to become percentages, right?
Yes, all these numbers we're pulling from the table are becoming percentages. So say we're, again, centered at 0 with a deviation of 1. 1.72 is approximately right there. And now you have the words more than, so I am coloring to the right. And there is my picture. All right, so we're all good. Now I use my Z formula. 1.72 minus 0 all over 1 equals 1.72. Again, I keep iterating this because in a few minutes, these are not going to be 0, 1 no more. We'll actually have to do some math. But for now, because they're 0, 1, they're not too bad. So I got 1.72. So now I go to my table, find my value for 1.72.
Wait, so it doesn't matter if it's coloring on the right or left, as long as it's just the wording?
We'll get to that in a second. But for now, we're okay.
So I'm still solving it the way I did before?
Correct.
Okay. And I have the answer, I think.
All right, what you got?
I have 9.9573.
9.573, you said?
Yeah.
0.957.
Yep, that's what I got. Anyone not get that wants to ask how? All right, no one's commenting, so I guess we're good. So here is our issue now. I think that was Ben talking, so good job, Ben. Your table is colored to the left, right? So that means this is 0.957, not 2. Eraser. 3. That's not what I want. That is the opposite of what I want. And anytime we have the opposite, we should use what rule?
The complement.
Complement rule.
The complement. So to
Yeah.
find our answer, we do 1 minus 0.9573, and we get 1 minus 0.9573. 0.0427. And that is our answer. So, Ben, you were correct. We were still going to do everything the same way when we're colored to the right, except for we have to do one extra step. We take our answer and we subtract it from 1, and we then have what we are looking for.
So it's pretty much just finding 95 or 0.9573 plus 0.0427 equals 1. You want it to equal a whole number.
It always has to equal 1.
Okay.
Yes, every time. It will always equal 1, because rules of probability say the total area has to be 1. So just like in chapter 5, we had to make sure our probability distribution function sum to 1. Our normal distribution function has to equal 1 if I combine everything on the left and the right. All right, how are we doing? You want another one to the right, or you want to move on to the next type?
Give it to me, man.
All right. I'll keep this and I'll move on. So now I want to find the probability I am more than 2, but yeah, we'll leave it like that. But less than 3. So the first thing we should do is draw a picture. Ooh, that's a horrible normal distribution, but that's all right. Centered is still at the mean, and we're going to stick to 0. Our standard deviation is still 1. There is 2. There is 3. Now, because I am more than 2 but less than 3, I color between. All right. So just like we were doing before, I have to find my z's. Now, in this case, I'm going to have 2 z-scores. I am going to do 3 minus 0 all over 1, which just equals 3. And then I'm going to do 2 minus 0 all over 1, which just equals 2. So now I have to get how many values from the table?
2.
2. So find me the 3 and find me the 2. And then I will put my answer up in about a minute. All right, let's see here. So 2.00 is 0.9772. So 0.9772. And 3.0 is 0.9987. 0.9987. All right. So there's the two z-scores I got in the red boxes.
Agreed.
All right. So now we got to think through this for a minute. If I am at the 3, which I'm going to color blue, and I color to the left, no, not erase, dang it. I put my green back in here. All right, back to blue. I'm at the 3, and I color to the left. That is all of that, right? That is what that number equals. Now, if I color from the 2 to the left, that is what all of that equals. So the piece that I still want is the green piece, right? So if I take these two values, 0.9987, and I subtract 0.9772, I get, let's see, I can do this math. That's 5, that's 1, that's 2, and that's a 0. I get 0.0215, which is the amount there in the green. So that is my answer. So basically the 3 steps for today. First step, color. So create a new page. Step 1, color. Right, color and draw. Step 2, find z-score or scores if we're doing a between problem. Step 3, find probability in table, or probabilities. I'm just gonna put it in S because I'm lazy. If you're doing more than one z-score, then you have to maybe do step 4. I'm gonna spell this right. Manipulate. Manipulate. That's probably not even close. Your answer based on coloring.
Hey, Chris, I have a question.
I have an answer.
So are we, just remind me, do we always subtract the larger from the smaller?
Yes.
Okay.
Yeah. If you ever do the smaller from the large, you're gonna get the same answer. It's just gonna be negative. Remember, we can't have negative probability, so that's.
Oh, yeah. Okay, thank you.
You're welcome. So, how do we manipulate? Well, if we're doing if we're right, so I'll put this in a different color, right? If we're right colored, we do 1 minus our step 3. If we're between colored, it's high minus low, step 3. Yeah, I ran out of whiteboard. Step 3. And that's it.
No, it's not.
That is it. That's all I can ask you. Less than, more than, and between. Now, again, just like with the test 1, the hard part is the words. So you got to think of all the words that mean less than, more than, and between. But as long as you can get your color drawn and you can read this table, that is it.
I'm having trouble reading your whiteboard.
Yeah, I know it's kind of a thing. So I wish I could type on the whiteboard, but I can't. The good news, I think, let me check. Am I still logged? No, I got to see him connect. Let's see. C, Toma. I'm gonna look at my notes to see if if I at least typed them out for this. Chapter 6. It is saved as a PDF. And remember, if you go to my notes, there is a little discussion spot where you can ask questions or email me. So, and I think I posted a video on all of this too. Yeah, it's kind of written out in Word. It is written out in words. It's not kind of. With the technology piece, I don't know if it's written out very math heavy, so some of you may or may not like it. What part are you having trouble reading? The blue?
Yes.
I have a question too.
Yes.
What did you mean by high? Are you saying high minus low?
Yes, the numbers from
Okay,
step
okay.
3.
Okay.
Yes.
I didn't.
So your two options here. So manipulate your answer based on your coloring, right? Because if you're colored to the left, you're done. There's nothing to change. You're colored to the same way the table is. So that's good to go. So left is easy. Left, get off eraser. Left equals done. Right? Step 3 is your answer. If I am colored to the right, this is the way I'm colored, and I have to do 1 minus my answer from step 3. Step 3 answer. If I'm colored between, try to give myself a little more room and write it a little slower. Then I take my step 3 high answer and I subtract my step 3 low answer. Right? So if I go back here, that's what we did here. We took 0.9987 and subtracted 0.9772 and got 0.0215. Right? So if I want to put my labels to this, here's step 1, here's step 2. My answer in the box is step 3, and then there is my step 4. If I go back one more page, here I am colored to the right. So here is step 1. I drew my picture. Here is step 2. I found my z-score. Here is step 3. I got my probability from the table. And then here is my step 4. I had to subtract it from 1 because I am colored to the right. If I go back one more page, here is step 1. I drew my picture. Here is step 2 where I calculated my z-score. Step 2 says. Here is step 3 where I found my probability, and I'm done because I colored to the left, so there is no step 4 in this case. So what really, really, really helps you is making sure you do not skip step 1. Now, do you have to do step 1? No. Do I think you should do step 1? Oh, heck yeah. Right? Because it is going to make sure you know what to do on that final step. Because steps 2 and 3 don't change. Every single time, step 2 and 3 was the same. Calculate z-score, find probability. Calculate z-score, find probability. Yes.
So every time you give us 2 numbers, is it always going to be looking for the in-between?
Yes.
Okay. Thank you.
Yep. And it's kind of written out in words. And the words on the course page are way more detailed than what I'm writing on the screen, because I have a recording to go with it. But so I would probably encourage you to look at both. So any questions on finding probabilities from the table? All right. So now, what if I want you to do this? Still draw my normal distribution, still with the mean, still with my standard deviation. We're going to stay at 0, 1 for a few more minutes. Now, I want to know what value is in bottom 5%? All right. So there's my question for you. What value is in the bottom 5%? So bottom means I'm somewhere down here. My color. Now the issue is if I am in the colored region, remember the colored region are probabilities. That means this colored region is 0.05, which also means this is the answer to step 3. My drawing here is step 1. The part I am missing is step 2. And so, how do I do that? Well, I still need to use the formula. Right? And this is where we've lied to you. There is no algebra. Because now we have to do algebra. So, 5%. Whichever number you want to look at. That is the number in the shaded region. If I am in the shaded region, then that means I am the numbers inside the table. So, everybody, go look at your tables. If I go to your negative z-scores and go to the very bottom number where it has negative 0.00, and you get the answer of 0.5000. I am in the bottom left corner. And then look over at the positive z-scores and go in the top right-hand corner at 0.00, and you see I also have 0.500. Because that is telling me when I am dead center, I have colored half of the graph. Right? And the reason this helps you solve this problem is 5% is less than 50%. So therefore, my answer is somewhere on the negative side. Does that make sense?
No.
Good. Good that you spoke up. Not that it makes sense. All right. To remember, all these numbers, if you're looking at your chart right now, so I'm trying not to move my screen, but I will if I have to. Notice, so go in the go to your, where it says table A2 on the negative, and you notice the smallest number there is 0.0001, right? Now go to the positive side and go to the very bottom where it says 3.50 and up, and you get an answer of 0.9999. That means all of these probabilities are somewhere between 0.0001 and 0.999, which basically is saying all these numbers on this table are between 0 and 1. So if you look at the numbers inside the chart on the right positive side, notice all of those probabilities are greater than 50%. All the numbers on the negative side are less than 50%. So since I want 5%, that has to be less than 50%. So I have to be somewhere on the negative side. Did that help clear it up at all?
Yep,
Okay.
1000%. Thank you.
So now that we all agree we're on the negative side, here is where we play Easter egg hunt. Probabilities are all these numbers inside the table. You have to look through all of those numbers and find 0.05. Remember, this is not a z-score. Do not go to the z-score 0.05. These are probabilities. I am somewhere in the mix of all of the numbers inside. So I have to go find 0.05.
So is it exactly 0.05?
You want to get as close as you can.
Okay.
So we're
In this case,
the
isn't
block,
exactly.
it's not on the side.
It's not on the side. Z-scores are on the side. Probabilities are in the middle.
Okay.
And you notice, and I picked this one specifically on purpose, where it's supposed to be a 0.05, there is a star. It's almost dead center in the negative side.
And what
And
is
if you follow the arrow down, you see the answer becomes negative 1.645. This is extremely important. Who does not see where I got negative 1.645 from? That's good. So we all found it?
Mhm.
Nice. Perfect.
Can you explain the star again?
The star is one of the special cases. That's why it's written at the bottom. Yeah, there's two special cases. There's a special case for 5%, and there's a special case for 0.5%. That's the only reason they have stars. Everything else doesn't have a star, so you just pick the number that's the closest. And we'll do another one where we have to pick the closest one in a minute. But the reason there's a star there, that's a special case. And the special case for this one is 1.645. Because if you look at the chart, there is no 5%. There's a 0.505 and there's a 0.0495. There's not an exactly 0.5. And in this case, there's a star there in its place because it's a special case. So the negative 1.645, that is my z-score. So now I put it into my formula. Negative 1.645 is my z value. X is what I am looking for. So I put an X in its place. Then I subtract my mean, which is 0, divide by my standard deviation of 1, right? And because I have 0 and 1s, X in this case equals 1.645. So the value that goes right here is 1.645. Negative 1.645. Negative 1.645 is the bottom 5%. Any questions on this one? right.
Can we do one where there's not a special case?
Yes.
So, can we do one like that's just kind of shows up on the chart without having to do the arrow?
Yeah.
Like,
Do you want me to get an exact or one you have to estimate?
um,
We'll do an
estimate.
estimate.
Yeah.
So
So
I'm just going to clarify
Yep.
again. Do you have to give us the mean and standard deviation every time?
I do.
Okay.
For our course, I do. Not in real life, but in this course, yes, because we don't know how to calculate it. And I'm not teaching you how, because you have to do calculus. All right, so I draw my thing. Mean, standard deviation of 1, mean of 0. Now I want the bottom, horrible bottom 75%. So I go to my table. Oh, not eraser. I color this way because it says bottom, and we know everything in here is 0.75. So now I have to go to my table and find 0.75. Now, is 75% greater than 50%?
Indeed.
Indeed. So that means I have to be on the positive side. That's supposed to be a greater than, sorry. So now I'm on the positive side looking for the number 0.75.
Okay, I'm not understanding, like, which one, how you decide if you're going to be looking at negative or positive. I don't understand what you just said, I guess.
All right, so my mean's in the middle. If I am exactly at the mean and I color to the left, that is 50%. If I'm exactly at the mean, okay? If I am less than the mean, that is the negative side. If I'm bigger than the mean, that is the positive side. So that's why I keep asking about this 50%. If the percentage I'm looking for is smaller than 50%, then that means I have to be on the negative side. If the percentage I know is bigger than 50%, then I know I have to be on the positive side. And because 75% is bigger than 50%, I have to be on the positive side.
Gotcha.
The good news, if you don't remember this, it's okay. Because if you start on the negative side, there is no number anywhere on that side that's close to the number 0.75, which will force you to go to the right side. I'm just trying to show you a trick so you can speed up the time versus going through both charts trying to find this number. Does that make sense?
Yes, makes sense now. Thank you.
Yep. So going to our chart, looking for 75%. And is there a 75%?
No, but close.
Okay, so what numbers did you get, Ben?
It was 0.7517.
So Ben says he got 0.7517. Anybody get anything else? What did we all get? 0.7517.
0.7486.
So there's a 0.746, right?
Yeah.
So
Yeah.
we're looking for 0.7500. So notice this one is 17 away, while this one is 14 away.
Okay.
So which is the better?
The 0.7486.
The true answer is either.
Oh, nice.
I will take both. And the reason is, this is where statistics, we get argumentative, right? If I want the bottom 75%, if I use the 0.7486, I don't include everybody because I've cut off 14% of them. I'm at the 14, right? But if I use the other number, I've included 17 a little bit more. So now this is where statisticians just argue. Is it better to go a little bit more or a little bit less? It depends on your philosophy. Do you want to be a little more cautious or a little more optimistic? You know, are you a person that's half full or half empty glass? You know, or do you just want to use math to figure out which one's closer? Both answers are correct. I would take both answers because it really comes down to your belief. And there is no hard math rule. So these are both correct. Now, we're not finished though, right? Because these are just probabilities. I don't want probabilities. I want my z-score. So what is my z-score for each of these? So 7486 is a 0.67, I think.
Yeah.
Looks like I'm reading my chart right.
Yeah, it is.
0.67. And for my 7517, it's 0.68. And you can see why this is not a huge difference, right? We're off in the 100th spot. You're either 60.67 or 0.68.
I'm a little lost.
Okay. Can you help me?
Okay, I see like how you got those numbers. It's the 0.68 and then 0.67 where I'm like, wait, hold on a second, where did those come from?
So go to your table and find 0.7486.
Okay.
Now move one finger all the way to the left and you find the 0.6.
Oh, okay.
And
It's
then-
that dude. All right. I got
Yeah,
you.
yep, good question. These are my z-scores,
Okay.
and they're
Oh,
both,
crap. I don't know how I write that in my notes in a way I'm going to understand.
yeah, that's the tricky part. That's why we're going very methodical through each one of these very carefully, because the good news is if you get this table down today, this is basically all of chapter 6. The only thing that changes is I change the mean and the standard deviation, and you actually have to calculate a z-score. But once you finish step 2, everything else is the same. It never changes.
Okay.
So that's why I want to make sure we're comfortable reading this table, because if you can do it for this, the rest of the chapter goes a lot smoother. If you don't understand this, when we go into the next section, it's just going to become worse. So that's why I want to make sure before we end today, which we have about 20 minutes left, everybody understands this table. So just to recap, the numbers inside the table, those are probabilities. The numbers under where it says Z, so the far column to the left and the top very, very top row, those are z-scores. Those are events. So when you're doing problems, if you're given an event, that means you can find a z-score, which means I'm looking for a probability. If I'm giving you a probability, that means I'm inside the table. I have to work my way out, and I am looking for an event. And when you read the questions, it'll help because it'll say, what is the probability, which tells me I have an event, or it will give me probability in the question, therefore I am looking for an event. How are we feeling on 6.1?
Feeling good.
Decent.
I feel
Nice.
like
Very
I'm
good.
not more confused.
Good. All right, so what I want to do is I'm going to do one problem of 6.2, and then I'm going to probably call it, and we'll start on 6.2 Wednesday, because it'll be a good refresher anyway.
Could I just ask one question before you move?
You
on?
can ask anything you want.
Is that z-score the answer? So like 0.60
Yes.
is the answer? Okay, thank you.
Yep. All right, because everything in the real world, very few things have a mean of 0 and a standard deviation of 1, correct?
Excuse me, Chris. I'm sorry. I had a question still.
Yep. What's up?
So you don't have to plug that back into the formula after you find this?
Well, and that you're supposed to, but because it's 0, 1, we didn't have to. This one, we will have to.
Okay.
Yes, you should always plug it back into the formula, but because we had a 0, 1 problem, the number won't change.
Okay. Thank you.
But this one, it will. Yep. So what if we have a problem where, say, the mean is 50? All right. We'll make it even something we can relate to. Let me get rid of 50. Say the mean is 16 ounces, right? Medium-sized cup of coffee, I guess that's what size that is. Maybe it's a large. I don't know. I don't serve coffee. But 16-ounce beverage. And the machine that fills the cup has a standard deviation of 1/2 of an ounce. All right? So because if you work in any fast food, no one measures up the cups. You put it to some machine, push a button, and it just fills it for you, right? So we're going to come in and make sure our machine's filling our cups properly. So the machine is programmed to fill a 16-ounce cup within a 1/2 ounce. So what is the probability that a cup is filled at 15.5 ounces? I will put or less, just so we can color. So 15.5 ounces or less, right? So then we come over here. That's a ugly 15. 15.5 has the word less in it. So I am coloring to the left, to the left, sorry. There is step 1. Step 2, calculate our z-score. Well, the formula again is x minus mu all over sigma. So again, I highly encourage you to put in parentheses. So now I have 15, not point, 15.5 minus 16 all over 1/2. And what does that equal?
-1.
-1. Perfect. So now we are back to where we were. We now go to our table, find -1.00. It is a z-score, therefore it is an event. So I just go to my z column and find -1.00, which gives me an answer of 0.1587. So there's a 15.87% chance that the cup is filled 15.5 ounces or less.
Can I ask a question again?
Of course.
So actually, you know what? I can probably figure out the answer on my own, or maybe it's not even relevant, but
It's always relevant. Go ahead.
I don't know that it is. So if there's a 15% chance that it's going to be filled 15.5% or less, you know what? Let me figure it out on my own, and then if I still have the question, I'm gonna ask.
Okay. Any other questions?
Yes.
Go
I
ahead.
have to figure out how to English this question. So you get your -1, and then that turns into 1.587. You found that on the chart thing.
Correct.
I was writing stuff while y'all found it on the chart thing, so I never actually saw it on the chart thing.
No, you're
So-
fine.
I'm getting all confused, like a big old meanie pants. Because I didn't do that part, because my brain was somewhere else. And now I'm trying to find it on the chart, and I don't know what I'm doing.
So fine, we got a z-score of -1.00, right?
Okay.
So go to -1.00. So find -1.0
Mm-hmm.
and
And
then
that's-
go over
There's the
one
thing.
spot,
Okay.
one spot, and there's the 1587.
Okay, that it makes sense. My brain just doesn't remember that's the thing I'm supposed to do, even though it makes 1,000,000% sense.
So the key to it is, let me see if I go back to my notes here.
It's like a little stem leaf plot type thing.
These are the steps, right? Color and draw, find z-score, find the probability in the table, and then maybe have a step 4. If we're colored to the left, we're done, so we don't have a step 4, right? So we come back to the page we were just on. Yeah. There's step 1 circled, step 2 circled, step 3 circled. Because we colored to the left, there is no step 4, and we are done.
That makes sense.
I have a question now.
Yes.
So just to make sure I'm like analyzing this correctly, is the 15.87% like basically telling them that that's the percentage of how many times it's not filling correctly to 16 ounces?
It's basically not, you're right, it's not filling correctly, but it's not filling correct. It's 15.5 ounces or less in this case. If we were to put 16 in there, then we would have found it up to 16. But in this case, we only found it up to the 15.5 ounces based on the problem.
Up to that. Oh, okay.
Yeah.
Thank you.
So basically, if I'm the boss of this place that sells coffee, and like I'm okay selling anyone coffee that's at least 15.5 ounces, right? What percentage of my customers am I jipping? Well, I'm jipping 15.87% of them.
Okay. Thank you.
Yep. Because in real life, typically what happens is we never actually get to 16 ounces, right? If we all went to Dunkin' Donuts and bought a coffee, the chance that every single one of our cups of coffee are filled exactly, if we took it to like the lab and measured it exactly at 16 ounces, is pretty much going to be 0. It's never going to get that precise. It'll get close, spillage, all these different things that happen. The machine cut off too early, went a little longer. So as a company, I'm okay if my customers lose a half an ounce, but I don't want to lose more than a half an ounce. So based on my calculations right now, 15% of almost 16% of my customers are getting gypped in their coffee based on my guidelines. That make sense?
Yeah, it makes sense. Thank you.
Yep. And it really, like, it's bringing this into a real world example. This is exactly what's going on right now with the coronavirus. And if you watch the news and they keep talking about flattening the curve, people are doing analysis with using the normal distribution as a model. And they are trying to take something that looks like this and make it look more like this, because we're trying to cut out that many people dying or getting the disease based on stuff like social isolation, doing online classes. That's what the president and all the people talking about models is talking about, flattening the curve. They're trying to bring the normal distribution down, right? And countries that have done poorly with this, Italy has not done well with this, and that's why their curve looks like this. I'll just go to a new chart, right? This is kind of Italy. They're spiking. Or versus North Korea, which have already started to limit things, their curve looks like that, right? So that's where what we're learning right now is being used every single day to try to figure out how we stop the spread of this virus. So flattening the curve is what they're talking about. They want to make your normal distribution short and stubby. And there's a nice real world example for what we're doing today.
I have a question kind of off topic.
Yep.
Are you pushing back the homework date that's due next week, I think it is?
I have already changed the dates in the system, I thought. I could be wrong. Let me double check. I think I got booted out of CM Connect. I did. Yeah, so yes, I've changed the dates based on the courses changed, and I've updated the syllabus as well.
Okay.
Let me double check to make sure I'm not lying to you. So if I go to coursework, homework 3 is due April 8th right now. So when is April 8th?
Okay, and that wasn't the original due date.
Was it?
I don't know. That's why I asked.
I might push it back in. We'll see. Well, you can definitely get a good jump on it right now because we've covered somewhat of 6.2. Well, next class we'll easily finish 6.2. And let me look at the syllabus. I'll tell me if I got to change it because I know I've updated the syllabus. I thought I changed all these dates though. I know I changed this. Let's see. When am I supposed to finish chapter 6? Oh yeah, I'll definitely have to change it. Yeah, chapter 6 we don't finish April 13th. So yes, I do have to go in and change the coursework. I really thought I changed that though. Yeah, so it's going to change. You can get an extra week.
Okay. Thank you.
Yep. I'm actually doing it right now so I don't forget. Homework 3. Edit this assignment. It is now going to be due April 20th. With a turn in date. Oh wait, we had 2 weeks to submit your homework, right? So that should go to May. Yeah, it's also the end of the semester. Yep. So now it's correct on the thing, and I'll go in and make sure it's correct on Pearson as well. All right. Any other questions?
I have a question,
Yep.
and it might, I don't know, whatever. So for the test on Pearson, and I only ask because I do my homework on Pearson, but it always has those little things where like, if you put in like a wrong decimal or you're doing something, whatever, like it just doesn't tell you exactly what you need. So it marks you wrong if you put in like 0.25 instead of 1/2 or something like that. You know what I mean? Like not the incorrect answer, but whatever. Is that going to be the same on the test where if we're not putting in like a hyphen or whatever, it's going to mark us as wrong?
Yes, but I'm going to review to see if your answer is close, and if it's just a typo, then I'll adjust your grade.
Fabulous. Okie dokie.
Yeah, because that's the problem with the computer grading it. It's going to only give you credit for the perfect answer, and there isn't partial credit. So I will go through and I will check people's partial credit. And that will kind of help.
Thank you.
I
Yep.
guess I have another question about like Pearson tests too.
Mm-hmm.
Do you like hand pick like the questions that are on the test? Because I know sometimes like I have an issue with like Pearson puts on questions that like I've never really learned, or like I haven't learned in a way that I've been taught in class. So I'm just wondering if like your questions are going to be like handpicked according to like what we've learned and kind of like how we're learning it.
Yes, it will be. And this next test isn't too bad. So I don't think we'll have an issue with that, but because the questions are going to be very one sentence, basically exactly what we were doing today. You know, what is the probability you're less than this? What is the probability you're more than this? What is the probability you're at least this? You know, Pearson's not going to know if you did steps 1 through 4. It's just looking for the answer to step 4, right? So I would encourage you to do steps 1 through 4 because it'll help guide you. But yes, I will handpick the questions where their wording will be very similar to the wording I'm asking you. And it's really going to come down, you know, to stuff like, you know, all Pearson is going to ask you is this. You have to know that once you see a question like that, that I now have to do steps 1, 2, 3, and 4. Does that make sense?
Yes, it does. Thank you.
It's not going to walk you through the 4 steps. It's just going to say, and it'll write out the problem. Actually, it'll look more like this kind of question. This is what it will tell you. You know, what is the probability that a cup is filled at 15.5 ounces or less when cups have a mean of 16 ounces and a standard deviation of 1/2? It will give all of that to you in the scenario. And then I'll have multiple parts. What is the probability it's less than 15 ounces? What is the probability it's more than 17 ounces? What is the probability it's between 14 and 13 ounces? So it'll ask questions. I'm going to try to make it very, again, scenario-based type questions. So they should look very similar to this. And if you do the Pearson homework, it'll look very similar to the Pearson homework. But again, you can still do my coursework. So in this case, as much as I don't try to guide you on which homework you do, because it is 100% in your case, I would say the test is going to look more now like the Pearson homework than it is going to look like the coursework homework, because of the fact it is being done through Pearson, versus the first test was more like the coursework homework because it was a test I handwritten, versus this one is going to be one out of a computer lab. Does that make sense?
Yes.
Still allowed to do your homework compared
Yes,
to
you would. Yes, you still can do my homework versus the Pearson. You can do either one that you choose, but you still have to have a Pearson account because of the fact the test will be on Pearson. And depending on really how well test 2 goes, if we do a final or not on Pearson, if test 2 becomes a pain for all of us, then I'll probably try to find something else. If we get really comfortable with Zoom, then maybe I will take the last 2 classes and turn them into mini Zooms where you can present your project. But we'll decide that within the next 2 weeks. That way people can decide if they need to do project 2 or not. Right. And then
Okay.
if we do lean to presenting our projects, and then what I ended up doing is making test 2 optional, project 2 mandatory, and then you can take test 2 to throw out test 1's grade if you want. So we will make a decision as a class in the next 2 weeks. I'm indifferent to it. But I just want to make sure I give you the right tools to make sure that you're successful.
I have a question about the test.
Yep.
Is the test timed in any way, or is it this?
I haven't decided that. It will be at least timed in the aspect that you will have to complete it on the day that it's assigned.
Okay.
I may put a time limit on it. I may not, I don't know, but it will be done within one day. That will be that I can guarantee. I will tell everybody the day that it opens, and you'll have to complete the test within 24 hours. And then what I'll probably do is not put a time limit on it, but what I'll probably end up doing is you have to complete it in one setting. So you can't save it and come back to it later. You will have to, once you start it, you will have to complete it.
Okay. But
And
it's not gonna be
it-
something like, "Hi, do a test in 20 minutes," or something completely obnoxious.
No. And when I write the test, even though I know you have an extra amount of time, I am still going to write the test that you should have been able to do it in the 90 minutes, just like we were in the classroom.
Okay.
So I'm not going to try to make some crazy hard test just because it's now take home. I'm going to make it so you should be able to do it in 90 minutes, but I will, just like in the classroom, there'll be more time allocated if you need it. But it'll probably be somewhere, 15 to 20 questions, that you should be able to do in 90 minutes.
Questions, do you mean like, here's question A, and then all of it's like sub questions or something?
I will make, there'll be 15 to 20 parts, just like test one.
Okay.
Yeah, so if there's a question that has multiple parts, then I just knock the questions down. I'll make sure, like I said, it'll be something that can be done within the 90-minute time frame. But I won't, even if I put a time limit, it won't be 90 minutes. It'll be at least 3 hours. But I'm probably not going to put a time limit. I'm probably just going to tell you must complete it within, like I'll say, we're going to take tests on April 27th, and you must complete the test sometime before April 27th ends.
Okay. So like, say the test becomes active or able to be taken at midnight that day, you have from midnight on the day that day started to whenever the heck that day ends at midnight.
Correct.
Whatever. Okay.
Correct.
Cool.
Any other questions? All right, so I am going to stop recording.